On to problem number 14, and this is the last problem. Exercise 2, chapter 1, solution of equations. Here we go. By suitable transformation, reduce the equation. It's a biquadratic equation, by the way, to an equation in which x cube term is absent. Okay, we need to convert this or transform this into another equation where this x cube term is absent. Okay, and hence solve it. Wonderful. Let's begin. This is what has been given in the question. Take a look. A biquadratic equation, degree 4, that's your given equation. 4 degree, 4 roots, alpha, beta, gamma, delta. What you need to do is to transform this into another equation where this x cube term is missing. And that is going to be your required equation. We don't know. We still don't know what the roots are. Okay. We can begin with this equation. We can take the sum of the roots. Alpha plus beta plus gamma plus delta is equal to something. What is it going to be equal to? Sir, negative, positive, negative. Okay. Sum of the roots, by the way, is equal to negative of plus 16 divided by 1. And let me write this. That is minus 16. Done. Let me make some space. Now, what you guys have been instructed is that you have to convert this into this sort. Okay. You have to completely make sure that this x cube term is absent. And for that to happen, the coefficient of x cube has to become 0. So how do you reach 0 from this 16? This is going to be your task. Sir, if we add plus 16 to both the sides of the equal to sign, RHS will automatically become 0. And this 16 can be split up. What we can do is alpha plus 4, beta plus 4 and so on. Okay, 4, 4, 4, 4. It is 16. Still the same. And this has become 0. Now we are getting an impression. It is that the moment you increase the roots from alpha to alpha plus 4, you automatically will get an equation or a required equation where the x cube term is missing. Okay, or beta to beta plus 4, automatically you'll have an equation. There will be no x cube term. That is what the idea is. Can you find that equation? Yes, sir. What we'll do is we are going to take a look at this LHS of this algebraic equation, that is this polynomial f of x, and we are going to divide this f of x by x plus 4. We can say that. Okay, when I say x plus 4, you can also say x is equal to negative 4, right? So we are basically, this is where the concept of diminishing the roots or increasing the roots come into the picture. Whenever you encounter such problems, what you really need to do is divide f of x by x plus 4 or x minus 4, whatever the case is. Okay, it is the successive remainders that we are interested in, and then we are going to arrange them in a specific order so that we have the required equation. So keep watching. This will be over in the next 2 minutes. Here we go. Divided f of x by x equals minus 4. Take a look at the coefficients. 1, 16, 83, 152 and 84. Let me use the synthetic division technique. Here we go. Copy paste 1. Minus 4 into 1. 16 minus 4. Minus 4 into 12. Okay, keep on repeating this process. Okay. Done. That's stage 1 and the remainder. Obviously, there is going to be remainder. Right? Copy paste. Minus 4 into 1. 8. Minus 32. 3. Minus 4 into 3. Done. 0. Okay, so another remainder. Third remainder, fourth remainder and fifth remainder. This is how you'll achieve them. Copy paste. Minus 4 times of 1 is minus 4. 8 minus 4 is 4. Minus 4 into 4 is minus 16. Minus 13. Copy paste. Minus 4 into 1 minus 4, and this becomes 0. If you observe carefully, this is x power 4. The highest power over 4. Okay. This is nothing but 0 into x cube. And you can clearly see that this x cube term has been completely eliminated. This is x square. This is x. In fact, with the x cube term, you can observe the x term has also been eliminated. Okay. Plus 36 is going to be equal to 0. Let me write them down properly from bottom to top this way. Okay. Agreed? All right, sir. This is very easy to solve. In fact, it is a biquadratic equation, but we can solve it like a quadratic. So you can see 36. Okay, 9 4 is 36. 9 plus 4 is 13. Okay, so split it up. Minus 9x square minus 4x square. Take x square as common, and here take 4 as common. X square minus 9 as common. X square is equal to 9 comma 4. So x will be equal to plus minus 3 and plus minus 2. So this is your answer. Is this your answer? No, sir, this is not our answer. What our answer is, this is the required equations roots. These are the roots, these 4 roots. Plus 3 minus 3 plus 2 minus 2 are the roots of this equation where the x cube term is missing. What we guys are supposed to calculate are the roots of this biquadratic equation where the x cube term is still present. Let me take you back to the previous slide. If you watch, we are supposed to calculate alpha, beta, gamma and delta. What we just calculated were the roots for this required equation where the x cube term was missing. You saw that. What you've got right now is alpha plus 4, beta plus 4 and so on. Okay, so these 4 values that you've got are for alpha plus 4, beta plus 4, gamma plus 4 and delta plus 4, which I've written down like this properly. You just need to solve these 4 equations, all of them having 1 unknowns. You're going to get the values of alpha, beta, gamma and delta as -1, -7, -2, -6. By the way, the first time I solved this problem, okay, the moment I reached at this junction, I thought I've got the answer, and I checked at the back of the book and to my surprise, the answer was completely different. The reason it was different because I was supposed to calculate the roots for this biquadratic equation where the x cube term was present, and hence these are the final values of the roots. So students, if you find this content helpful, do like and share the video with all your friends and classmates so that they can also benefit. Do subscribe to the channel and also press the bell icon so that you stay notified with all my latest content. This is Manas Patnaik signing off. Take care and have a nice day.